Hello, my name is Michael Kim, and this is my lab report 3 for Physics 2212. Okay, to start, the purpose of this lab is to use magnets and a magnometer to calculate and observe magnetic fields with varying distances. The fundamental principles that this lab aims to explore is the magnetic field created by a magnet, and this is done using the following formulas. You have the Biot-Savart law, you have the magnetic field of a dipole on an axis, and the magnetic field of a bar. In order to calculate the magnetic field caused by a magnet, we are using a magnometer to record and observe the strength of the fields. This could be done on an iPhone or any device. With this information, we can plug data into an Excel document and calculate average values for magnetic fields at varying locations. After recording data, I was able to graph the natural log of bx versus the natural log of r, and using the line of best fit from the data, we can plug in values into the b bar equation and the b dipole on axis equation in order to calculate mu. This mu value will be used in the code in order to find values in ideal circumstances. As for the measurements of a 45-degree angle, we calculated the b net value to be 5.836 times 10 to the negative 5. One important adjustment that had to be used in the calculation was that the magnetic field caused by Earth was observed to be negative 2.4 times 10 to the negative 5, and this had to be corrected for in order to find a correct value for the b net at 45 degrees. In the first section of coding, we were required to fill out the function for dipole B, and the way this was done was using the Biot-Savart law in order to find the actual b values for a given mu and a given r. To show these values in action, we found 6 points, 2 on axis with the magnet and 4 that are perpendicular to those positions. And this is shown with multiple arrows in the perpendicular directions as well as 2 on axis directions. In the section of coding, we were also required to find the magnetic field at a 45-degree angle similar to our experimental version. And similarly to the perpendicular and on axis values, we used the dipole B function. These are the visual results from the coding section. As you can see, there are 2 on-axis points in red and orange, 4 perpendicular values all in green, and a small 45-degree value in pink that shows the magnetic fields. As for what would have happened if we hadn't oriented our experiment to compensate for the magnetic north, using the exact same methodology, the results would likely be skewed greatly as the ln for bx would be off by the magnitude of however far the angle was. There is a simple solution, however, of subtracting the angle from the calculations to begin with, and most likely you would get a similar value to how you did originally. And as for what would happen if we sticked 2 identical magnets together end to end and ran the experiment the exact same way, the strength of the magnet would likely be twice as large, disregarding the change in distance from the original size, and as such the bx values would increase